Okay. John is getting a 25,000 loan with 8% annual interest rate to be paid in 48 equal monthly installments. If the first payment is due at the end of the first month, the principal and interest values for the first payment are closest to. Now, in this case, since there are 48 payments, so n is going to be 48. Interest rate that is given on yearly basis, annual interest rate must be divided with 12, and that will give you 8 upon 12, gives you 0.6667 as it is. You don't need to enter the percentage sign. So the amount that has to be redeemed, the amortization of the loan, $25,000 is to be repaid. What should be the payment? This is to be calculated, and the future value is 0. You simply punch in the numbers and press CPT. You should get your result. Let me do a few questions using our financial calculator, and here it is. All right, n is 48. Interest rate is 0.6667. 25,000 is present value, the loan that is to be paid. Future value is 0. Need to calculate the payment. It is 606.28. 606.28. Write it down, 606.28. This is not what was needed. We need to split the 606 into two components, because every payment we make to pay off the loan, some of it is interest, the rest of it is in principal part. So we will have to calculate the interest part and the principal part separately, and then we will be able to answer the questions correctly. So your total interest will be calculated on the original loan amount multiplied with the monthly interest of 0.6667, and when you calculate 25,000 multiplied by 0.6667 gives you $166.67. So it means out of this amount 606, 166.67 represents the interest, and the remainder would be your principal, and that would be 440. I think there's a little rounding off error, so this A is the correct answer. So we have split the 606 into its principal and interest part. First we calculated the payment amount, and then we charged the interest and split the amounts into two components, the principal payment and the interest. That makes A to be the correct option. Probably we use 0.6667, that's why there's a little marginal $3 difference, but nonetheless we got our result. Next question, given an 11% compounding quarterly for 2 years, compute the future value of 8,000 today. Right, we just have to make sure that we extract the information correctly, and then rest of it would be done by your BA2 plus. Simple. So there are, how many periods are there? Quarterly. In 1 year there are 4 quarters. It means in 2 years there will be total 8 quarters. The periods are 8. If the periods are in quarters, the interest has to be converted in quarters as well. So dividing 11 with 4, 11 upon 4 gives you 2.75. Present value is $8,000 today. Negative or plus doesn't matter. If you put PV negative, FV will be positive. If you write PV positive, FV would be negative. Doesn't make any difference. You will get your result. So payment is 0. You punch in these numbers, compute FV, you should get your result, and it should be B. I'm sure you have your calculators with you. Punch in the numbers and you will match the result, and I think it would work for you. We can do many questions this way rather than just punching the numbers on calculators and then spending 2 to 3 minutes per question. So we got it right, 9939. Next, now this is the question that I would do using calculator. What is the maximum an investor should be willing to pay for an annuity that will pay $10,000 at the beginning of each of the next 10 years? Mind the word beginning. It's an annuity due. It's an annuity due question for the next 10 years, given the investor wants to earn 12.5% compounded annually. Now, it's an annuity due question. We will have to first bring our calculation to beginning mode and then punch in the numbers. So first we can do it in 2 ways. Let me tell you, we can do it in 2 ways, but why don't we just focus on the smartest way to save time? Save time. We have a lot to do. Let us do it straight what we need to do using annuity due. So first what you should do, press the second function, press PMT, because right above the PMT it will convert you to the beginning mode, and then press the second again, and then the key on the face of it, enter. This will bring your calculator to the beginning mode. Let me show you again. Second PMT, second enter. It was all in beginning mode. Second PMT, second set or enter, that will bring you to the beginning mode. Now let us extract the numbers so as to plug it and get the result straight away. What is the maximum investor should be willing to pay for an annuity that will pay 10,000 at the beginning of each of the next year? So it means this is the payment, write 10,000 positive. Given the investor wants to earn 12.5% compounded annually, so no change in the interest rate, you can simply plug it in 12.5, right? Present value is to be calculated. Future value is 0. And what is N? Now this is something that you have to take care. Maximum investor should be willing to pay for an annuity that will pay 10,000 at the beginning of each of the next 10 years, given the investor wants to earn 12.5% compounded annually. 10 periods, 12.5% interest. Plug in the numbers and you will get your results straight away. 10, quit first, 10N, 12.5 is interest, PV is to be calculated, 10,000 PMT, future value 0, compute present value. 62,285 gives you the present value straight away. So we just punched in the right numbers and got a result that makes A to be the correct option. And don't forget, that's important, you have to quit the second function at the beginning mode, otherwise there might be mistakes. Now back to end. All right, moving on. The First State Bank is willing to lend $100,000 for 4 years at 12% rate of interest, with a loan to be repaid in semi-annual payments, which means 4 years must be converted into semi-annual payments, 8 payments. Interest must be divided with 2, that is 6%, that's important. And given the payments are to be made at the end of each 6 months, how much will each loan payment be? Now, the periods are 8, interest rate has been adjusted 6, PV, the present value is $100,000, because this is the loan amount that you will receive now. How much you will have to pay, future value 0, simply press these numbers into these functions and press CPT payment, you will get your result. Punch it in and your result should be 16,103.59. All right, so done. A is the result. Next. Suppose you are going to deposit $1,000 at the start of this year, $1,500 at the start of the next year, and $2,000 at the start of the following year in a saving account. How much money will you have at the end of 3 years if the rate of interest is 10%? Now, since all these payments are to be taken to the future, so these payments are being made at the start of each period, so it's going to be, first payment is being made now, this one, and then this one. So which means this would be multiplied with 1.1 raised to the power 3, 1,500 into 1.1 raised to the power 2, and this 2,000 into 1.1 raised to the power 1. So when you multiply these, let me do it with a simple calculator. 1,000 times 1.1's cube give you 13331. 1,500 times 1.1 square give you 1815, and 2,000 multiplied by 1.1 it'll give you 2200. If you add all these future values, these uneven cash flows were taken to the future using this formula. I'm sure you remember, FE is equal to P into 1 plus R raised to the power N. So for these 3 periods into the future, year 1, 2, 3. For this 2 periods into the future, year 2 and 3, and for this for year 1 only. So added all these, 18, 1, 5, 13, 3, 3, 1 gives you 5346. So the future value of these uneven cash flows is A5346. Gentlemen, speed and accuracy, that's what you need in professional certifications, speed and accuracy. And that's what our agenda is. Peter Wallace wants to deposit $10,000 in a bank certificate of deposit, COD. Wallace is considering the following banks. Bank A is offering 5.85 annual interest compounded annually. Bank B is offering 5.75 annual interest compounded monthly. This is compounded annually. So compounded annually means effective annual rate would be 5.85. Because 5.85 annually, compounded annually, effective rate and annual percentage rate, they are the same. But for Bank B, it's 5.75 annual interest rate compounded monthly. And for Bank C's 5.7 annual interest rate compounded daily, that is 365. The question says, which bank offers the highest effective interest rate? So we don't need to calculate for Bank A, it's already there. For Bank B and C, we'll do it. Effective interest rate can be calculated using your calculators. Second, quit. Use second ICONF, that is interest rate conversion. First is 5.75, nominal rate is 5.75. Enter up arrow key. Frequency of compounding is 12. Enter up arrow key and then press CPT. So it means the effective annual rate for Bank B is 5.90. Right here, 5.90, right. For the next one, the nominal rate is 5.70, 5.70. Enter up. Frequency of compounding is 365. Enter up, and don't forget to press CPT. It's 5.86. So now we have 5.86 for Bank C, 5.85 for Bank A, and the highest is being offered by Bank B, that is 5.90. Right, even 5 basis points, but this is the one that we are going to go for. The highest effective rate is being offered by Bank B, so that makes B to be our correct option. Okay, moving on. Vega Research has been conducting investor polls for the third state bank. They have found the most investors are not willing to tie up their money in a 1-year or a 2-year certificate of deposit unless they receive 1% in case of 1 year and 1.5% in case of 2-year COD, right? So for 1 year COD, they're expecting 1.1% at least, and for the 2-year COD, 1.5, more than they would on an ordinary saving account. If the saving account is giving 3% and the banks wants to raise funds for 2-year COD, remember for 1 year COD, the investors are looking for 1% premium. And for 2-year COD, they're looking for 1.5% premium. Since they are talking about the 2-year COD, so the investors would be requiring 3 plus 1.5, 4.5%. Right? So it's a straightforward question. No computation as such, simply. So 4.5%, and this represents a discount rate. It's not a discount rate. It's a forward-looking, it's a required rate of return. We are taking it from the point of view of the investor. Since we are taking the view of the investor, investors are induced through offering them a certain rate of return. They have the certain requirement from the borrower that they expect in return. So from the investor point of view, it is the required rate of return, right? It's not the discount rate. So this is 4.5 required rate of return, B to be the correct option. All right, moving on. Jamie Morgan needs to accumulate $2,000 in 18 months. Okay, this is to be accumulated, that's the future value. Needs to accumulate now, no, in the future. Let's see, let's read the whole question. If she can earn 6% at the bank compounded quarterly, we need certain adjustments. Compounding quarterly means this 6% must be divided with 4. 6 by 4 gives you a 1.5% rate quarterly. Okay, then 18 months. 3 months make 1 quarter. If there are 18 months, how many quarters do we have? We have 6 quarters. So we have 6 quarters, 6 periods. Interest rate per period, that is per quarter, 1.5. What else? We have been given 2000. Is it the future value or the present value? Needs to accumulate 2000. This is the future value, of course. Now the question is clear. It's a future value. That's what we need in the future. So the future value is 2000. There is no frequent payment or the recursive payment. All numbers are there for your TVM computations. Enter these all and press CPT, present value, and straight away you'll get your result. No twist in this question. Straightforward. CPT is 81829.08. No further ado. We can move on to the next one. The straightforward question. Which of the following statement about compounding and interest rate is least accurate? Mind the word focus is on least. Least accurate. Present value and discount rates move in the opposite direction. Absolutely no doubt about that. If discount rate is increased, your present value will fall. They move in the opposite direction and vice versa. If the discount rates are decreased, present value will go up. It's a correct statement. On monthly compounded loans, the effective annual rate EAR will exceed the annual percentage rate. Yes, because monthly compounding means there are 12 times compounding. The frequency of compounding is 12%, 12 times in 1 year. We can verify this idea. I think we have done it. Do we have some slide here to assist? No. So we've just seen it in the previous discussion, or we can just take an example. Let's say 10% annual percentage rate. If it is compounded monthly, the effective rate will be more than this, and this will verify the option B to be correct also. Let's do it. Second, 10% nominal rate, enter up. Frequency of compounding 12, enter up, and you will see is 10.47%. So you can see here that the frequency of compounding is 12, the effective rate would be higher. On monthly compounding loans, the effective annual rate will exceed the annual percentage rate. Annual percentage rate was 10%, whereas monthly compounded gave you annual effective rate of 10.47. This is a correct statement. We just verified it using the numbers. A is correct, B is correct. It has to be C then. All else equal, longer the term of the loan, the lower will be the total interest you pay. This is wrong. Longer the term of the loan, there is a maturity risk that has to be compensated. So longer the term of the loan, higher will be the total interest you pay. Shorter is the loan, you pay less interest. It's quite a common sense question. So this is an incorrect statement. This is an incorrect statement. C is incorrect. All right, moving on. Consider a 10-year annuity that promises to pay you $10,000 per year. Given this is an ordinary annuity, an investor can earn 10% on her money. The future value of this annuity. Straightforward question. Plug in the numbers. Ordinary annuity 10. Interest rate to be compounded yearly 10%. No present values to be calculated. The payment is to be made $10,000. You need to just calculate the future value. Enter all these. Press CPT and future value, and you'll get your results straight away. I'm sure you people have calculators in front of you. You're just punching in the numbers and getting the results. Verify your numbers. It has to be B. 159374, B it is. Next. Given an 8.5% discount rate, an asset that generate cash of $10 in year 1, $20 in year 2, and $10 in year 3, and is then sold for $150 at the end of the 4th year. What is the present value? Now you can't solve it in the normal conventional way. Now that is where practice comes in. Doing 100 easy questions won't prepare you for the exam. But doing 10 to 15 challenging, tough, frightening questions will prepare you for the war. So don't just do a simple question think that you're doing well. You should always love the questions that challenge you, because they are the one that prepare you. Always love the challenges, and that's what you need to succeed in your CFA examination. Now this is interesting. 8.5 is the discount rate, an asset that generates $10 in the first year, negative 20 in the second year, plus 10 in the third year, and then finally it gets you 150 at the end of the 4th year. We have to calculate the present value. Since these are not the regular recursive cash flows, we have to use some other approach for this question. What you will do, let me tell you, you will use your NPV function of your calculator. You will write CFO 0. For the first year, there is no cash flow. Right now, there is nothing. At the end of year 1, You get $10 positive, you press enter and down arrow key twice, means $10 is just once. When the cash flows are repeating, you will change. I will show you when there are repetitive cash flows. Frequency of $10 is just one, so there is no number you can see between these two down arrow keys. -20, down arrow key. Since it's a single cash flow, you write these double arrow keys downward. And then you have +10 in the third year, enter, double arrow downwards, and then you sell the asset at a net book value or at a net proceeds of $150. Again, it's a plus, enter. Now, all these cash flows have been entered in your calculator. You will press NPV button. You will then have to enter the discount rate, that is 8.5. Press enter, down arrow key, and press CPT, and you will get your result. You need to press CPT again. All right. Now let us plug in the numbers. Quit. Tables are clean, neat and clean. All right, let's get started. Second, initial cash flow, 0 right now. Down arrow key. First cash flow is $10 inflow positive, enter, double arrow downward. 20 negative, enter, double arrow key down. Cash flow 3 is positive 10, enter, double arrow. 150 at the end of year 4, enter, right? We need to calculate NPV. When you press NPV, the system will ask you what's the discount rate, 8.5, enter, down arrow key, and then press compute here, 108. So 108.29 is the present value of these uneven cash flows coming at the end of year 1, outflow year 2, inflow year 3, and inflow year 4. So this is the recommended approach to calculate the present value of uneven cash flows. If you have to calculate the present value of uneven cash flows, the future value of uneven cash flows, you will have to calculate the future value of each individual cash flow separately. But that is the way to do, that is the recommended approach. So that gets you C to be the correct option. Moving on, if $1,000 is invested at the beginning of the year at an annual rate of 48%, compounded quarterly, what would that investment be worth at the end of the year? First of all, when you say quarterly, and we're talking about the total period of 1 year, it means there will be 4 quarters, N is 4. Interest rate, 48, that is annual percentage rate, has to be converted on quarterly basis. So for that, you need to divide it with 4. 48 by 4 gives you 12%. 12% is the quarterly rate. N is 4. That is, in 1 year, there'll be 4 quarters. What do we need? If 1,000 is invested at the beginning of the year, if you invest $1,000 now, that's the present value. Outflow negative. There is no regular recursive payment. You just plug in these numbers. N is 4, 12% IY, negative 1,000 PV, PMT 0. Simply press CPT future value. You should get your result C. I'm sure you people are following and you're getting the results. MashaAllah, all of you have got it correctly. That is C. All right, next. Whenever a challenging question comes, I will come in action. Otherwise, I'll just lay down the working. You can just plug it in. And this is the one that needs my involvement. It says 3 years from now, an investor will deposit the first of 8 1,000 payments into a special fund. The fund will earn interest at the rate of 5%. These are recursive payments. Okay. What else? Thereafter, the fund will return a reduced interest of 4%. Now, for the first few years, for the first 3 years, the interest rate is 5%. For the first 5 years, it says. And after that, the fund will be reduced to 4%, compounded annually. So there is no compounding issues until the final deposit is made. How much money will the investor have in the fund at the end of 10 years, assuming no withdrawals are made? Now this question will be done in 2 parts. Firstly, there will be 3 payments, will be invested at the rate of 5%. Each payment is $1,000 for $1,000. And then subsequent to these 3 payments, there will be 5 payments of $1,000 each. And for those payments, the interest rate will be 4%. So the question will be done in 2 steps. First is the step 1. You make 3 payments at rate of 5%. Present value 0. You have to find out the payments are for $1,000 each. We just need to calculate the future value. This future value will then be reinvested, and for the next 5 years, together with the payments, you'll get the total future value of the payments. Now, let us first find out the future value of these payments using our calculator function. 3 is N, 5%, present value 0, payments that are being made 1,000, that's PMT. You need to calculate the future value, that is 3152. This 3152 is now being invested as the present value. This will be again invested. This is the step 2 now. Now the remaining period is 5 years now. The interest rate will fall from 5% to 4%. This investment at the end of the period 3 will be reinvested at present value. Consider it as a negative, that is outflow, 3152.5. And you will resume paying $1,000 again. You will continue paying $1,000 till the end of 10th year, right? How much money will the investor have in the fund at the end of the 10th year, assuming no withdrawals are made? So you will have to calculate the future value. So you have the data in front of you. You just have to plug in the numbers now. 5 is N, 4%, 3152.5 negative. That's the present value that has been accumulated over the period of 3 periods. And then there is payment that will go till the end of 10th year of $1,000, and you will have to calculate the future value, that is 9251.82, perfectly matching with your. So you will have a question like these where the payments are being split into various parts, and I recommend for beginners, it is recommended that you draw a timeline that will help you understand the idea better. I've just simply extracted the numbers and plugged it in the calculator. For the beginners, they must first draw the timeline, and then they should do their computation. That will be much helpful for them. Question number 14. The value in 7 years, N is 7, of 500 invested today, that is invested right now, it's a present value, at an interest rate of 6%, compounded monthly. When it says compounded monthly, you have to divide it by 12, that will give you 0.5. And how many periods will there be of 12 months? For how many years are we talking about? 7 years multiplied by 12. 7 multiplied by 12 means 84 periods. So there are total 84 periods. Interest rate on monthly basis is 0.5. Payment to be made, single payment. It's not a repetitive payment. It's a single payment invested now. What will be its future value? Simply plug it punch it in your calculator, and you will get your result. And I'm sure most of you got it absolutely right. That is 760. Very good. Question 15. A stated rate of 9% compounded semi-annually result in an effective annual rate of compounded semi-annually. This is your nominal rate. I'm going to write it as norm. Semi-annually means the compounding period, that is called the compounding per period, that is equal to 2. And you just have to calculate your EFF as per your financial calculator. Plug in the numbers and you get your result. Second interest rate conversion. Nominal rate is 9%. Enter up. Frequency of compounding is 2. Enter up. Press CPT, and there you go. 9.2025, and that is A. Don't select 9.3 because rounding off will give you 9.20 only, so that makes A to be the correct option. And A it is. Next. Bill Johns is creating a charitable trust to provide 6 annual payments of $20,000 each. 6 annual payments of $20,000 each, beginning next year. Annuity, ordinary, beginning next year. How much must Johns set aside now at 10% interest compounded annually to meet the requirement? Bill John is creating a charitable trust to provide 6 annual payments of $20,000 each. For this, what has to be paid now so as to ensure these payments become available in the future? For 6 years, what he must invest, interest rate is given 10%. You just have to calculate the future value 0. what should be the present value, what you should invest now. Simply enter these in your calculator, 6 and 10%, negative 20% for PMT, and simply press CPT PV. You will get your result. I'm sure you would have got your result, and very good. All of you got it correct. That's A. Moving on. As the number of compounding periods increases, what is the effect on the annual percentage rate and the effective annual rate? Here we go. That's what will assist us. When the compounding was done twice in a year, your effective annual rate was 6.09. When the compounding period was increased from 2 to 4, your rate went up. Further, as the number of compounding per period goes up, your effective interest rate goes up. APR remains same and ER increases. Yes, it does. Effective annual rate increases, but something that is very fine that you need to appreciate. Annual percentage rate is the same, but when the frequency of compounding is increased, your effective annual rate goes up. Yes, it does, but it increases decreasingly. It is increasing. The first increase was for 0.4%, then for 0.3% approximately, then for 0.2%. So it is increasing but decreasingly. So we do not have this fine requirement of the question. What we do see is that as the frequency of compounding goes up, your effective annual rate goes up as well. So that is the right answer. Otherwise, I think there is a question that will require this specific fine point that yes, EAR increases, but it increases decreasingly. It increases decreasingly. So in this case, A is the right answer. There is no such fineness tested, so that makes A to be the correct option. All right, moving on. An investor wants to receive $1,000 at the beginning of each of the next year. Beginning means it's annuity due. Each of the next 10 years, N is 10, with the first payment starting today, surely annuity due. If the investor can earn 10% interest, this is your interest per period. What must the investor put into the account today? Present values to be calculated so as to receive $1,000 cash flow stream in the future regularly. What he must invest now. N is 10. Interest rate is 10 as well. Payment that is making is $1,000. Future value is 0. What must be the present value of the annuity due? Now, you just simply don't punch in the numbers. You will have to first shift your calculator. Second, PMT, beginning mode. It's an annuity due question, gentlemen. So second, quit. Now enter 10 is N. 10 is interest rate. 1,000 negative is your recursive payment. 0 is the future value. You need to calculate the present value, and it is 6759A. Please make sure to quit the beginning mode, otherwise there will be errors. Right now it's perfectly fine. So we got a result 6759. That makes A to be the correct option, and A it is. Why? We don't need that. We just simply know how to do it. Why do we need to know multiple methods? Yes, you can adopt any method you want, whatever you feel convenient with. I don't mind that. But whatever works for you, use that method and keep on using it frequently. Next question, 19. An annuity will pay 8 annual payments of $100. 8 annual payments of $100. So you are receiving its plus. When the first payment to be received 1 year from now is ordinary annuity. If the interest rate is 12% per year, what is the present value of this annuity? Very simple, straightforward question. The payment period is 8. Interest rate is 12. Present values to be calculated. Future value is 0. Punch in these numbers and simply press CPT PV. You get your result, and it should be 496.76. I hope it's working. You have your calculator with you. You just need to punch in the numbers, and we will save time for more challenging questions. So A is the result. Now this is the one that needs my attention. A local loan shark offers 4 for 1 on payday. 4 for 5 one day. I mean, they offer you a loan of $4, but on your payday, which might be a weekly pay or maybe a monthly one, 4 for 5 means if you borrow 4, you will have to pay 5. $1 interest. What it involves is that you borrow $4 from him, loan shark, and repay $5 on the next payday 1 week later. You borrow $4 and after 1 week you pay $5. This is how loan sharks work. They charge excessive, extraordinary interest rate. How extraordinary? I will just show you. What would the stated annual interest rate be on this loan? Stated annual interest rate with the weekly compounding, assuming 52 weeks in 1 year. What is the effective annual interest rate on this loan? And select the respective answer choices closest to your number. First of all, you are paying an interest of $1 for a loan of $4. So 1 by 4 times 100, that is 25% for 1 week only. So this 25% per week. 25% per week. Very high. How many weeks are there in 1 year? 52 weeks. So 25 multiplied by 52, 25 times 52 gives you 1300%. This 1300% is the annual percentage rate. Look no further, click B and move on. But let's say if 1300 is present in A as well as C, then you will have to confirm this number as well. Otherwise, if you just need to guess, B is fine. Now we have the number annual percentage rate is 1300. Now we have to convert this annual percentage rate into an effective annual rate. And the result will frighten you. Okay, here we go. Second, interest rate conversion. Nominal rate is 1300. Enter, up. Compounding. How many weeks are there in a month? 52. 52 compounding in 1 year. Enter, up. Press CPT and look at this 10.947544 million percentage. In other words, 10,947,544%. Wallah haram haza. It's extremely high interest rate, which definitely required that person to be killed. This is too much. Effective annual rate is 10 million percentage. So that makes B to be the correct option, and B it is. Okay, we go. Looks a little challenging one, a bigger one. I love questions like these that they require Smith. Just a minute. Alice Coors, hedge fund manager and avid downhill skier, was recently granted permission to take 4 months sabbatical. Sabbatical, basically, it's a period of paid leave for employees. They might go somewhere to just relax and have fun. So this person, Alice Coors, he has been given a permission for a sabbatical to enjoy for some time off. It's always advisable to spend some time off for at least 1 week. That will relieve your pulsating nerves. You will feel relaxed and then you become more effective. Always recommended. So after your CFA exam, you should give yourself 1 week at some good place, maybe Goa or maybe somewhere in some suitable place. So during the sabbatical, scheduled to start in 11 months. This is the period after which he will take leave of 4 months. Coors will ski at approximately 12 resorts located in Austrian, Italian and Swiss Alps. See, this is what you call fun. Coors estimates that she will need $6,000 at the beginning of each month for expenses that month. She needs $6,000 for every month, and she will spend 4 months. Remember, this is the period she will spend, and there are 11 months remaining for her sabbatical. She has already financed her initial travel and equipment costs are done. Her financial planner estimates that she will earn an annual rate of 8.5% during her saving period and an annual rate of return during the sabbatical of 9.5%. So it means first she will have to invest for 11 months. These 11 months will get her 8.5% return, and after that the rate will go up to 9.5%. How much does she need to put in her saving account at the end of each month for the next 11 months to ensure the cash flow she needs over her sabbatical for a period of 4 months after these 11 months are over? how much you need to deposit in 11 months? It's a very good question indeed. And what would be the size of each payment? Gentlemen, for this, I recommend for the beginners, you need to draw a number line. But we got the idea that for 11 months period, she will have to put a certain amount of money. And for the next 4 months, she will receive the amount of money that she can have fun with. Gentlemen, first of all, she will receive $6,000 for 4 months. For that, how much you need to invest? So starting first with this one, N is 4, 9.5% for the whole year, since we are talking on monthly basis, so 9.5 upon 12, 9.5 divided by 12, it's 0.79166, right? Every payment she will receive will be for $6,000 in order to cover her expenses. Future value is 0. We need to compute that what should be the present value at the end of the period when these 11 periods are over. Remember, she will need the first payment at the start of the month 4, which means it's an annuity due question. Remember, this is an important point to remember. It's an annuity due question because she needs money at the start of the 4 months period when she starts enjoying in these lovely places in the European regions. So let's start first with the function conversion. Second, PMT, second and set. This will convert your calculator into beginning mode. It's an annuity due because she needs money at the start of month 4. And she needs at the start, not at the end of the month. She needs spending money. So she has to have the money at the start of each of the month. So that's why it's an annuity due question. Let us first calculate the present value and then we will calculate the second aspect to it. And here we go. Second quit. Starting first with the second PMT, second enter. Now it's in the beginning mode. 4, second quit. 4 is the period. Interest rate on monthly basis is 0.79166. PV is to be calculated. 6,000 what she will receive. Future value is 0. We have to compute the present value. It is 23,000. This is what she needs. This is what she needs. 23,718. And what was in points? 71 or 72, 0.72. 0.72. Now, this was the first phase. That's what she needs to have so as to receive $6,000 for each of the 4 months at the beginning of each month of her sabbatical. Now, the investment part. This is the withdrawal part. Now we have to see the investment part. She will be investing money for 11 periods. Investment will generate 8.5 on monthly basis. 8.5 must be divided with 12. 8.5 divided with 12 gives us 0.70833, right? Now this present value at the end of 11 periods is the amount that we will have in the investment account that will pay her $6,000 every month. Now we have to calculate what should the payment be that she will make in order to receive $6,000 in each of the 4 months for her sabbatical, right? So she needs this future amount. This future amount will be invested here as an outflow, and that will result in $6,000 receipt at the start of each month. So we are talking about the future value of 23718.72, right? And so what would be the payment amount that we need to? PV must be 0. Now we need to calculate the payment she has to make every month now. So let us, I hope you got the idea. Let me repeat. First we took what she will receive every month, $6,000 for 4 months at the start of each month. So it's annuity due. This is the interest rate. Future value is 0. So for getting $6,000 every month, this should be the amount of investment, present value of investment at that point. So this present value, in fact, it will be the future value of her investment, which she will make every month for 11 months at this rate. Present value 0. Payment is to be calculated. This is the future value for this investment, and we have to calculate the payment she will make. So first we will need to convert our calculator into the end mode. Quit. 11 payments. Interest rate is 0.70833. Present value is 0. Future value that she needs in the account in order to receive $6,000 every month at the start of each month, 23718.72. This is what she needs in the future in that account so as to receive $6,000 every month. So this basically represents your future value. What she must pay every month is 2080.95. This should be her payment every month, 2080. Now it makes much sense now. This is what she will be investing for the 11 months at this rate so as to achieve this much as the future amount. This future amount will represent as a present amount for this annuity. This is the investment as a negative. At this interest rate, 0.7916 per month, will generate a 6,000 of inflow at the start of each of her month she will spend in the sabbatical, for the sabbatical. So that was a little twisted one, but when you split the question in two parts, then accordingly you can. Yes, timeline will always help, but once you get the idea, you can do it straightforward. Otherwise, timeline is always recommended when you get a question like this. It makes things much more easier. All right, moving on to question number 22. As the number of compounding period increases, we just discussed this a little while earlier through this table. What is the effect on the effective annual rate? It increases, we know that, but it increases decreasingly. It is increasing, but at a decreasing rate. So that is a clear, straightforward question. It's a C1. Increases at a decreasing rate. Next. If $10,000 is invested in a mutual fund at that returns 12% per year, 12% per year, after 30 years, the investment will be worth. A very straightforward question, no twist in it. Present value $10,000. Payment is 0. Simply punch in these numbers, CPT future value, you will get 299,599 positive. So that makes A to be the correct option. Straightforward question for practice. Now, this one is good. Find the future value of the following uneven cash flow stream. Assume end of the year payments. Every payment is at the end of the period. See, look at this. We have to calculate future value. And it is not a repetitive amount. So don't use the TVM function. It will simply require you to calculate the future value of each of these single cash flows, time consuming. What you can do, since we have to calculate the future value, interest rate is 12%. And this payment is being made now or at the end of the period? At the end of the period. So you can draw the timeline or you can do straightforward. This is being made at the end of the first year, so it will be multiplied with 1.12. 12% being the interest rate, raised to the power 1, 2, 3, 4. This will be multiplied, 3,000 multiplied by 1.12 raised to the power 3, 1.12 raised to the power 2, 1.12 raised to the power 1, and multiplied with 1.12 raised to the power 0. Simplify these simplifications, and their sum should give you a total of 58,164.58. Remember, the first one, negative 2,000 into 1.12 raised to the power 4 will be a negative number, negative 3147. Negative 3,000 into 1.12, these are the outflows, negative 4214.78. Rest of them will be positive. Simplifying these will give you the straightforward answer, no big deal. This is the only way, gentlemen. Unfortunately, uneven future cash flows will have to be solved this way. But calculating present value, you can use that CF naught function, 0, enter down arrow key. That will help, but for these, unfortunately, this is the way. Future value is equal to the cash in or out multiplied by 1 plus rate raised to the time period, which will be RF 4, 3, 2, and so on. So this is the only way I told you while doing the main overview. Unfortunately, that's the only way we'll do it. All right, so that gives you a total of 58,164. Next question, number 25. Here we have some regular cash flows. Here we can apply the TVM, and for these two we can do some shortcut. A firm is evaluating an investment that promises to generate the following annual cash flows: 5,000 for the first 5 years, no cash flow for year 6 and 7, and then cash flow at year 8 and 9. What do we need? Given BBC uses 8% discount rate, this investment should be valued at the present value of this investment. So what you will do for these recursive cash flows, we can apply TVM. N is 5, right? What is the rate of interest? 8. Present value is to be calculated. Every payment is 5,000 since an inflow, plus future value is nil. Simply press CPT and you will calculate the present value, and let us do it. 5N 8 interest rate, 5,000 inflow at the end of each of the 5 years. This is PMT. Future value is 0. We need to calculate the present value, and this gives us 19963. 19963. All these are positive, so inflows is a positive NPV. For these 2,000, simply divide them with how many years it has till year 0. You can draw the number line. I normally simply plug in the numbers and get the result. For those who would like to use this method, we have 2 cash flows, one coming at the end of year 8 and other at the end of year 9. So in order to discount it, you will have to divide it with 2,000 divided by 1.08 raised to the power 8. And the 9th year cash flow of $2,000, it needs to be divided with 1.08 raised to the power 9, right? So 2,000 divided by 1.08 raised to the power 8, this will bring this 2,000 into present terms, and 2,000 divided by 1.08 raised to the power 9, it will bring this 2,000 to present terms. So converting these, first one will bring the cash flow to 1080.53, this one, and 2,000 upon 1.0 raised to the power 9 gives you 1,000.49. So bringing all these future cash flows in the present term, 19963 plus 1080.53 and 1000.49 gives you a total of 22,044.02. Marginal difference of rounding off, so that makes A to be the correct option. A it is. Next, the following stream of cash flows will occur at the end of the next 5 years. We have to calculate the present value. The present value of these cash flows. This is the one that you can use your financial calculator for. Negative 2,000, negative 3,000, and then these are the positive inflows. What you will do, I'll lay down the working. I won't recommend TVM here. I hope I haven't missed any question. Have I? No. We did 25th, now it's 26th. All right. So CF not, that is your 0, single arrow, $2,000 negative, enter, down arrow key twice, negative 3,000. You can use your calculator directly. This is for just illustration purpose. I'm writing it down. Enter, down arrow key, it's +1, then plus 25,000, enter, down arrow key, then you have 30,000, enter, down arrow key, then you press NPV. System will ask for the discount rate, which is given as 12%. You enter, down arrow key, and press CPT. You will get your present value. Let us do it. This one you can do, of course. The future value will require, let's say if these were the future values, you will have to calculate the future value of each individual cash flow separately. Okay, CF 0, enter, down arrow key. Unfortunately, we have some numbers present. 2,000 negative, enter, twice, down arrow key. 3,000 negative, enter, down arrow key twice, and then we have 6,000 positive. It's a single cash flow, so double down arrow, then 25,000, enter, double down arrow, and then we have 30,000, enter, double down arrow, and you need to press the NPV. Interest rate is 12%. I hope we get the right answer. 3304.14, that is the present value of these future cash flows, because your NPV table was not cleared, so yet we got the right answer. It's 33,004. This is the present value of these uneven cash flows, and that makes C to be the correct option. Compute the present value of a perpetuity with $100 payment beginning 4 years from now. Assume appropriate annual interest rate is 10%. As One gentleman suggested we should use TVM. Yes, the timeline will always help, but for beginners, it's recommended. If you are expert, you can simply plug in the numbers, get your result. Save time. It says compute the present value for perpetuity with 100 payments beginning 4 years from now. The first payment you will receive would be here, right? We need to calculate its present value at time 0. So what you will do, this is the $100 recursive payment at a rate of 10%. So what you're going to calculate, you're going to calculate the present value at the end of year 3. When you apply the formula for perpetuity, $100 divided by 10%, this will convert the stream of cash flows from year 4 onwards at the end of year 3. 100 upon 10% gives you $1,000. We are not yet there. This $1,000 has to be discounted to year 0. What you will do, $1,000 divided by 1.1 raised to the power 3, because it has 3 periods to cover to come to the year 0. So what did we do? $100 divided by 10%, it gave us the present value at the end of year 3. To bring this third year cash flow to year 0, we divided this $1,000 with 1.1 raised to the power 3. So this should give you the present value 1,000 divided by 1.1 cube. That is 751.31. So that makes C to be the correct option. All right. Renee Fisher invests $2,000 each year starting 1 year from now in a retirement account. If investment earns 8% or 10% annually over 30 years, the amount Fisher will accumulate is closest to what under these two streams? In case of 8%, 30 payments, 8% is interest, present value 0. The payment she will make $2,000. What would be the future amount? That's what we need to calculate. In case of 10%, 30 payments, 10% interest, present value 0. 2,000 is the recursive payment. What will be the future value? Simply punch in the numbers in your financial calculator TVM and you will get 225 and 330 as your result. Save time and move on. Now this is a good one. Optimal Insurance is offering a deferred annuity that promises to pay 10% per annum with equal annual payments beginning at the end of 10 years. Beginning at the end of year 10 and continuing for a total of 10 annual payments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember, it is starting at the 10-year periods. For an initial investment of $100,000, what will be the amount of annual payments? This is what you are paying now, $100,000. This $100,000 will be what amount at the end of year 10? So a single payment for 10 years at 10% rate, the present value is you're making a payment, so it's an outflow, $100,000. It's PV, no payment. So what will be the future value? Compute the future value. Let us first do it. Let us first calculate the future value. Quit. 10N, 10 interest rate. Negative is the present value, 0 payment. What will be its future value? 259,374. Let us write it down. 259,374.246. 259,374 simplify 0.25. Now, gentlemen, this is the single payment we invested in year 0, and at the end of 10th year, this is the value. What the next part of the question says. We have invested it in an investment account that generates an interest rate of 10%. What will be the amount we will receive in each of these years? How many time periods there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have to identify, is it an annuity due or is it an ordinary annuity? Let me write down the relevant detail on this side of the TVM data. Rate of interest is 10. This amount, which has accumulated over a period of 10 years, It is now an investment in this annuity. This 259,374.25, which has accumulated over a period of 10 years, this basically is an investment in the account as an outflow point, this 259,374.25. It's being invested for 10 years, right? How much payment this annuity will make when the future value is 0? We have to determine, is it regular annuity or is it an annuity due? That's an important point because we have yet to decide this. Optimal Insurance is offering a deferred annuity that promises to pay 10% per annum with equal annual payments beginning at the end of the 10th year. It means the first payment will be received here. That's the first payment is at the beginning. It means it's an annuity due. It may be the end of year 10, but the first payment is being received at the start of the period. So it's basically an annuity due question. So for this, we have to set our calculator to beginning mode by pressing second, PMT, second, and set, and plug in the numbers. Let's do it. Second, PMT, second, set. Now it's in the beginning mode. Quit. Enter the data. We have 10N. Interest rate 10. 259,374.25 that has been invested in this account is negative. This is the present value. Future value is 0. What would be the regular payments that we will receive? 38,375.51. That makes C to be the correct option. And as you can see, C it is. 30th one, if 10 annual deposits of 1,000 are made, outflow $1,000. 10, what is the compounding? It's just straightforward question. 20 years, that makes N, is it? If 10 annual deposits of $1,000 are made into an investment account earning 9% starting today, it's an annuity due. How much will it be worth after 20 years? So this is a two-step question. In the first step, we will calculate what will be the future value after 10 years, and that future value will be then converted into another future value after another 10 years. So let's do the first step 1. Number of periods for the first phase is 10. Interest rate is 9%. Present value, let us clear this up. It was the payment. N is 10. Interest rate is 9%. Present value is 0. We are making a regular payment of 1,000 annuity due at the start of each period. We need to calculate the future value. Once we calculate the future value, the next step would be to invest it again for next 10 periods because we have to reach till the end of 10th period. Interest rate is 9%. Whatever the future value will come, it will become the present value for the future amounts, no payments, and then you will calculate the future amount. Let me show you how it will work. So good question, apparently a one-liner, but it has a lot of twists. Step 2, in the first step, you will calculate the future value after 10 years. That future value will become the present value for the next 10 years. With 0 payment, 9% interest, you will calculate the future value. Let us do it. Second payment, second set, first in the end mode. Or are we making the first payment right now? Second set, second enter. The beginning one, its first payment is being made right now. It's an annuity due. Let us make sure if 10 equal annual deposits are made into an investment account earning 9% starting today, definitely it's an annuity due, and we have rightly said it so. 10 is N. Nine is interest. 0 present value. 1,000 negative is the payment. We need to calculate the future value, second future value. It is 16,560. This 16,560, which is an inflow, will become an outflow for the next step, 16,560, which is the present value positive. It's an inflow 560. It's an outflow there now. So you have 10 additional years at 9% where this present value will convert into a future value. But this time you have to do it on annuity ordinary basis. Second PMT, second enter, second quit. 10 is N. 9% is the interest rate. Investment now is 16,560 negative, and it's going to be your future value, present value. Your payment is 0 now. CPT future value is going to be 39,204 approximately, 39,203.54. So this will be the value of your investment at the end of the 20th year. Question number 31. Wei Zhang has funds on deposits with Iron Range Bank. The funds are currently earning 6% interest. If he withdraws $15,000 to purchase an automobile, the 6% interest can best be thought of as what? Since he had to sacrifice the 6% interest in order to purchase an automobile, so this represents an opportunity cost, sacrifice, balidan. So we can call it as an opportunity cost because this is what he has to sacrifice in order to purchase an automobile. So this represents an opportunity cost, so that makes B to be your correct option. Next. Justin Banks just won a lottery and is trying to decide between the annual cash flow payments or the lump sum option, either a single payment or regular annual cash flows. He can earn 8% at the bank, and the annual cash flow option is $100,000 per year, beginning today for 15 years. Beginning today. Now this is an important piece of information. When it says beginning today, that means annuity due. So beginning today for 15 years, what is the annual cash flow option worth to banks today? You have to set your calculator to beginning mode by pressing second PMT second set. Then there are 15 periods. I'm sure you people have your calculators with you. Since there is annual compounding, so interest rate would be 8. Payments that he will receive, you can write a plus sign. Inflow means positive, outflow you can put a negative sign with it. We don't need the future value. You just first need to set your calculator in the beginning mode, enter these numbers, simply press CPT PV, and you should get your result. And that should be, I'm sure you people are doing it, 924,423.70. And don't forget to exit the beginning mode. You need to press second PMT second set. That is very, very important. If you do not exit the beginning mode, you will make mistakes in your next question. So this is very essential. So you got your result. That was a straightforward question. Moving on. What is the maximum price an investor should be willing to pay today for 10 years annuity that will generate $500 per quarter? That's your periodic payment, $500. And such payments to be made at the end of the period, that is ordinary annuity, given he wants to earn 12% compounded quarterly. 12% compounded quarterly means it has to be divided with 4. That means interest rate would be 3%. Since we are talking about 10 years and there are 4 quarters in 1 year, it means there will be total 40 periods. Future value is 0. Enter all these in TVM, CPT, PV, and you will get your result, and it will be negative 11557.39. Right? 40 payments, interest rate 3 quarterly, 500 is the individual payments for 40 periods, FV 0, press CPT, PV, you get your result. That makes B to be the correct option. Next. What is the effective rate of interest on an investment that generates 12% APR, annual percentage rate, compounded quarterly? Now for this, let us do this with the calculator function. Here we go. How do we convert our 12% compounded quarterly into effective rate? For this, you press second, interest rate conversion. Nominal rate is 12%, 12, enter, up. What is the compounding per year? There are 4 compoundings per year, that is enter, up, and then press CPT. Your effective rate is 12.55. Effective rate is 12.55 for an APR compounded quarterly. So that makes B to be the correct option, and B it is. Alright, next. Given investors require an annual return of 12.5%, a perpetual bond, a bond with no maturity or due date that pays 87.5 per year in interest should be valued at, it's the present value of perpetuity, it's equal to the return divided by the rate, and it's a straightforward question. $87.5 divided by 12.5, that will give you $700, and this represents the present value of the perpetuity. That makes A to be the correct option. Straightforward questions, yes. If a 45,000 car loan is financed, you need an outline, just a basic outline, straight jump into the battlefield. You just need an outline, and then that's where you need practice, more and more practice. If a 45,000 car loan is financed at 12% over 4 years, what is the monthly car payment? First of all, the periodic payments are monthly. We are talking about 4 years, so 4 times 12, that gives you 48 periods. Interest rate must be converted on monthly basis as well. Present value of the loan right now is 45,000. What exactly do we need? Monthly payments. So that means future value 0. Press CPT PMT and you will get your result. Yes, they are simple, but at least they are speeding you up. You are getting speed and accuracy. That's what you need on professional certification. Speed and accuracy, and that's only possible through practice. Practicing what? Questions. More and more questions. So that's C straight away. That's your result. Moving on to question number 37. What is the present value of a 10-year $100 annual annuity due if interest rates are 0? If there are no interest rates, then you simply multiply these 100 payments. And how many payments are there? 10 payments. $100 times 10. This is simply the present value. Since the interest rates are 0, that is your straightforward result. This is not right. Why not solution? Interest rate if 0 means there is no discounting, no impact of discounting. $100 will mean $100 in present terms. So 10 such payments mean you will have total $1,000. That makes C to be the correct option. Next, if a person needs $20,000 in 5 years from now and interest rates are currently 6%, how much do they need to invest today if the interest rate is compounded annually? If there is annual compounding, periods would be 5 as given. You need $20,000, so this is the future value that you need. No periodic payments, it's not an annuity. Interest rate, straightforward annual rate 6%. What you need to invest right now, punch in these numbers and you will get your result. It's going to be 14,945. That makes A to be the correct option. Hardly 30 seconds game. No big deal. Do as many questions as you can. Given $1,000 investment compounded monthly, that means interest rate would be 1%. Find the future value after 1 year. 12 periods. Interest rate is 1. 1,000 investments and outflow right now, negative 1,000. No periodic payments. You need the future value. Punch in the numbers, CPT, FV, you get your result. That's 1126/825. That's in the points. So 1126.83 roughly. That makes A to be the correct option. Next, if an investor will receive an annuity of $5,000 a year for 7 years. Now this is a good question, yes. Difficult question, easy question, average question, they are all questions. Question hota hai. You have to do it, whether it's simple or difficult. And this is a little challenging one. An investor will receive an annuity of $5,000 a year for 7 years. The first payment is to be received 5 years from today. If annual interest rate is 11.5%, what is the present value of an annuity? So doing a question like this, it is recommended, in the early stages at least, to draw a timeline. Once you have a timeline, it will make much more easier for you to know what to do. Now, since we are talking from a periodic payment for 7 years, the first payment to be received 5 years from today. So 5 plus 7, starting from first payment is on 5th year, you will just start from year 0. 0, 1, 2, 3, 4, 5, and taking it till onwards, 6, 7, 8, 9, 10, 11, 12. We are not yet sure will it be 11 or 12. Let us read the information again. It says that you will receive 7 payments and the first payment will be received 5 years from now. That's where you will receive your first payment. 5 years from now. Starting from here, there will be 7 payments. This is the first payment, second, third, fourth, fifth, sixth, seventh. Means there are 11. Means years. There will be 11 years. So there will be 7 periods. There is no periodic compounding, just 11.5. We need to calculate the present value. This present value we calculate for these payments will be received here in year 4. When we calculate the present value of these 7 payments received in year 5, 6, 7 onwards till year 11, when you will calculate the present value, it will be the present value at the end of year 4. So 7 periods or payments, 11.5% interest rate, present value that will be received at the end of year 4, PV4, payment $5,000, future value 0. Simply press CPT and you will get your present value at the end of year 4, and it's going to be 23,185. This 23,185, this is the present value at year 4. Now we have to discount it back to year 0. Now in the second phase, this was the first step. In the first step, we discounted these 7 payments to year 4 at the end of year 4. This payment at the end of year 4 now would be the future value. 23,185 will now be the future value to be discounted in present terms, and there are 4 periods, 4 till 0, 4 periods, interest rate is the same. We have to calculate the present value. There is no periodic payment anymore. You simply enter these number 4, 11.5, 0 and 23,185 CPT, PV, and you will get the present value. It will be exactly 15,056.56 or C. Right? I'm sure you people are getting the correct results. Yes, you are. 41. Given the following cash flow streams, year 1, 2, 3, 4, these are the cash flows, 4,000 in year 1, 2,000 in year 2, 0 in year 3, and negative 1,000 in year 4. Use a 10% discount rate. The present value of this cash flow stream would be, I recommend NPV arrangement for this. Cash flow at year 0, 0, enter, single arrow key. Cash flow at the end of year 1, $4,000, since the frequency is just one cash flow, enter, down arrow key twice. Then $2,000, enter, down arrow key twice. Then the third year, there is no cash flow. In the fourth year, there is negative 1,000, enter, down arrow key twice. You press NPV, the system will ask for the discount rate, that is 10%. 10, enter, down arrow key CPT, you will get your present value of these cash flows. Let's do this using our financial calculator. All right, here we go. The first payment is 0, enter, down arrow key. This is your cash flow function. $4,000, enter, down arrow key twice. 2,000, enter, down arrow key twice. Third year cash flow is 0, 0, enter, down arrow key twice. And the fourth year cash flow is negative 1,000, enter, down arrow key twice. Calculate the NPV the system will require for the interest rate. I thought I cleared the table. Let's see, 10, enter. Okay, compute. It gives you 4,606. This is the present value of this cash flow stream from year 1 to year 4. So that makes B to be the correct option. And as you can see, B it is. Next, a good one again. Jim Franklin recently purchased a home for $300,000 on which he made a down payment of $100,000, which means the loan amount is net of these two. 300,000 less 100,000, that's 200,000. He obtained a 30-year mortgage, 30 years mortgage, to finance the balance on which, the balance $200,000, on which he pays a fixed annual rate of 6%. If he makes regular fixed monthly payments, now this is the point that needs consideration, monthly payments. If there are monthly payments involved, that means these 30 years will involve 360 periodic payments. Interest rate will have to be divided with 12, 0.5%. The loan amount that we are discussing is net of 100,000, that is $200,000. Now, what is exactly the requirement? If he makes regular fixed monthly payments, what loan balance will remain just after the 48th payment? Loan balance when 48th payment is made. It's a good question indeed. Okay, so if we draw a timeline starting from this 1, 2, 3 and so on till 48, we will first have to calculate what is the periodic payment. There are 360 periods. Interest rate is 0.5. Present value which you have received from the bank is $200,000. Periodic payments are to be calculated. When you enter all these CPT PMT, your periodic payments would be negative 1199.10. These are your periodic payments. So you make these payments for 48 periods, because it said what is the loan balance when you make 48th payment. So it means out of 360, if you make 48 payments, so what would be the remaining period? That will be 312. Right now, take N to be 312. Interest rate 0.5. This is what we need to calculate. Periodic payments are given here. That's 1199.10. Future value is 0. Now for these payments, if this is the periodic payment, this is the interest rate, you will get PV at the end of 48th year. This will calculate the PV at the end of the 48th year, and this will represent the principal of the loan. If you enter all these in your TVM, press CPT PV, you will get 189,228.87, which if rounded off gives you B to be the correct option. So that this question required two-step computation. First, we need to calculate what is the periodic payment, total periods, interest rate, the principal we received now, FV0, we calculated the periodic payments. We have made these payments for 48 periods. What is the remaining period? 312. Interest rate 0.5. The payment 1199.10. If future value is 0, if you calculate CPT PV, this will give you the present value of the loan principal at the end of 48th period. This is something that you still have to pay in the next 312 periodic payments. So that gives you B to be the correct option. Moving on. 50 years ago, an investor bought a share of stock for $10. The stock has paid no dividends during this period, yet it has returned 20% compounded annually, of course in capital appreciation, over the last 50 years. If this is true, the share price is now closest to. Now there are 50 periods involved. Return is 20%. The initial investment representing PV was minus 10. There was no periodic payment. We just have to calculate CPT future value. Enter all these in your TVM, 50, 20, negative 10, 0, and you'll simply calculate future value and it'll come out to be 91, quite a sizable number, $91,004. Now this would be the share price today. Simple, straightforward questions. Do every question, whether it's simple or difficult. This will increase your speed and accuracy, and these are the only two things you need on the exam. No recitations, just the ability to solve questions within the allocated time. Next, how much should an investor have in the retirement account on his 65th birthday if he wishes to withdraw $40,000 on that birthday and each of the following 14 birthdays? It means we are talking about total 15 payments, and he wants to withdraw the first amount on his birthday. The first payment will be received on his birthday, so it's going to be annuity due. First payment is to be received now. Assuming his retirement account is expected to earn 14.5, what are we required to find out? How much does he need to invest? How much should he invest now so as to receive $40,000 on his 65th birthday and then 14th following birthdays? So in this case, since the first payment is to be received on his 65th birthday, so set your calculator to the beginning mode, second PMT or BGN, second set. Total 15 periods are involved. Interest rate is 14.5. The present value of the investment to be made now is PV. The payments he wants to receive 40,000 per year for 14 years after his 65th birthday. FV0, you simply punch in these numbers, press CPT PV, and you should get, as per my computation, 274,422. This is what he should invest now, so as to receive 40,000 on his birthday, 65th birthday, and then 40 subsequent birthdays. So that's a straightforward question. Don't forget to quit your begin mode by second PMT second set. Your calculator must be in the end mode. Next, the real risk-free rate can be thought of. The real risk-free rate can be thought of exactly the nominal rate reduced by the expected inflation. First of all, I'm sure you would have got the basic idea from your preliminary readings. Nominal risk-free rate is equal to real risk-free rate, I'm just using the initials, plus expected inflation rate. This equation gives you approximation, not accurate. This gives you approximation, not accurate, right? So the real risk-free rate can be thought of as exactly the nominal risk-free rate reduced by expected inflation. No, approximately the nominal risk-free rate plus the expected inflation. We want to calculate the real risk-free rate. So real risk-free rate, nominal risk-free rate minus expected inflation. It is not exact. If you want to calculate the exact, for this we have a formula. 1 plus nominal rate is equal to 1 plus expected inflation multiplied by 1 plus the real rate. If you want to calculate the real risk-free rate, this is the formula we use. Since it didn't say anything like division and multiplication, so you're talking about this model, this gives you an approximate nominal risk-free rate. So nominal risk-free rate is equal to real risk-free rate minus expected inflation, plus expected inflation. So if you need the real risk-free rate, for that you need to deduct the expected inflation from NRF. But here he's either adding or approximately the nominal risk-free rate reduced by expected. That's correct. If you need this factor, real risk-free rate is equal to nominal risk-free rate minus expected inflation. Now this perfectly satisfies this arrangement. Since he didn't ask the absolute one, for this we have this arrangement. So that gives you C to be the correct option. And as you can see, C, it is given in the explanations. All right, next. This is a good one again, a challenging one. This is a good one, of course, a challenging question requiring some multiple steps to solve it. Natalie Brunswick, neurosurgeon at a large US university, was recently granted permission to take an 18-month sabbatical, a paid vacation, that will begin 1 year from today, exactly at the end of 12th month. Exactly at the end of the 12th month. During the sabbatical, Brunswick will need $2,500 at the beginning of each of the month, which means she needs this amount at the end of 12th month. When her sabbatical starts, she needs it at the start. So it's going to be annuity due. During the sabbatical, Brunswick will need $2,500 at the beginning of each month, since the sabbatical is starting at the end of 12th month. So this is she needs at the end of 12th month, means the first payment to be made at the end of 12th month. So it's an annuity due. Her financial planner estimates that she will earn 9% over the next year on any money she saves. This is on the saving. The annual rate of return during her sabbatical will be 10%. At the end of each month during the year before the sabbatical, how much should she save? That's a good question. How much should she start saving from today for the next 12 months? So she should have sufficient amount for 18 months with $2,500 paid at the start of each month. This is the first part that you should solve. Since she needs the first payment at the beginning of the sabbatical, so it's going to be an annuity due question. Set PMT, set begin. There are 18 periods. Interest rate during the sabbatical is going to be 10. So if you divide 10 with 12, it's going to be 0.833. Right? What's the payment she will receive? She will have to receive $2,500 for each of the next 18 months, starting from the start of the sabbatical. Future value 0. You press CPT and present value. This present value, gentlemen, since we have used the annuity due, if you draw the timeline in the beginning, you should, but as you become expert with practice, you just need to punch in the keys and you get your result. 12th, and then so on, onward till the end of our sabbatical. Since we have used annuity due, the present value has been calculated at the end of year 12. This PV which you have calculated by punching in these numbers, this PV is at the end of year 12. P12 using 18 periods, this interest rate, this payment at the start of each period with 0 FV gives you 41,974. This is what should be there at the end of the 12th month when her sabbatical starts. So the second step means that this would be the future value that she has to have in her investment account. So in this case, this is going to be the future value, 41,974. Now, this is the withdrawal phase. This is the investment phase. In withdrawal phase, you have calculated the present value that should be there at the start of 12th, at the end of 12th period, which will serve as a future value for the investment phase. How many periods will there be? Straightforward 12. Don't forget to exit the beginning mode. There will be 12 periods, but during investment phase, the interest rate is 9%. 9 by 12 gives you 0.75. Present value is 0 since she needs to make the regular payments, and that's what we want to calculate. How much should she pay every month, every year? So future value is this, and is 12, interest rate 0.75. You just have to press CPT and PMT. It will calculate how much do you need to invest every year so as to accumulate this much amount at the end of 12th period, and this amount will then be withdrawn from an annuity at the rate of $2,500 per month for the next 18 months so she can enjoy during the sabbatical. I hope it made sense. So this is what she needs to start putting in the account at the end of the first year. So this makes C to be the correct option. Next, an investor purchased 10-year 1,000 par value bond that pays annual coupon of $100. If the market rate is 12%, what is the current market price or value of the bond? So very straightforward question. 10-year is the period of maturity. Return discount rate to be used for discounting 12. What is the periodic payment you're receiving? $100. Amount at maturity received $1,000. So if plug in all these, punch PV, you will get 887. Straightforward, no twist in this question whatsoever. If an investor puts 5724 per year, starting at the end of the first year, ordinary annuity, in an account earning 8% and ends up accumulating this much, how much year did it take the amount to raise to $500,000? So there are, N is not given. Interest yearly, no compounding. Present value 0. Payment he's making every year is 5724. It's an ordinary annuity. The future value will be received after 5 years. It's 500, not 5 years. Years we have to calculate. $500,000. We just have to calculate the number of periods. Interest rate, PV 0. This is the periodic yearly payment. This would be the future amount. You have to calculate the number of periods. You punch in all the numbers. Your N should be 27. Straight TVM computation, no twist involved. Next, if an investment has an APR, annual percentage rate of 18% and compounded quarterly, its effective annual rate is closest to. We know what to do. Second quit, second interest rate conversion. Your nominal rate is given as 18%, 18, enter up. Compounding is quarterly, that is C/Y means 4 compoundings per year, enter up. Press CPT is going to be 19.25. Your effective rate is 19.25. That makes A to be the correct option. Gentlemen, speed and accuracy. That's what you need on professional certification. No recitations. Remember, it's speed and accuracy. And that's through practice. Paul Kohler inherits $50,000 and deposits it immediately in a bank account that pays 6% interest. Now other deposits or withdrawals are made. In 2 years, what will be the account balance assuming monthly compounding? If it's monthly compounding, you will have to convert monthly rate 6 upon 12, that's 0.5. Since you're talking about 2 years, how many months are there in 2 years? Of course, 12 into 2, 24. Interest rate 0.5. The investment you're making right now, it's negative 50. Negative means outflow. No periodic payments, CPT, FV, straight away you get 56,400 and there you go. B. Gentlemen, speed and accuracy. A certain investment product promises to pay this much at the end of 9th year. If an investor feels this investment should produce a rate of return of 14% compounded annually, what is the most he should be willing to pay for it? What is its present value? Straightforward. The question will start speaking with you. The more you practice, the question will start telling you how they will or how they should be solved. 9 periods, 14 is interest rate, present value is to be calculated, what it should be worth now. There is no periodic payment, and this is the future value, 25,458. This is the future value, and this is the rate. 9 years the period. What should be its worth now? Straight punch in the numbers and you'll get your result. I'm sure most of you have got it. It's 7828.54. This is how conventional accountants write it. I'm a professional accountant, by the way, and this is how we write points. So excuse me for that, but in CFA we don't do that. It's 7828.54. That makes B to be the correct option. B. Next. A stated interest rate of 9% compounded quarterly in an effective interest rate would be equal to what? Straightforward computation. Your calculator will do the deal. Here we put the compounding is quarterly. The interest rate nominal needs to be exchanged with 9. And there you go. Simple as that. CPT 9.3. Straightforward. You don't have to bother raise to the power this and that. Straight away your financial calculator will do the rest. 9.3. B. Next. Nikki, Ali and Donald borrowed $15,000 to help finance their wedding reception. The annual payment loan carries a term of 7 years, an 11% interest rate, respectively the amount of the first payment, that is interest, and the amount of second payment, that is principal. Now this is a good question. It's a good question. Yes. Good and bad are all there. Simple, complex. But it's the fluency you need. This is the amount of loan. This is the interest rate, annual compounding. The question says what is the specific part of interest in the first year payment and what is the part that represents principal in your second payment? Good question indeed. Since the loan term is 7 years, interest rate is 11. Loan amount which you have received right now is $15,000. Right? What is the periodic payment? That we need to calculate with FV0. If you punch in these, you will get 3183.23. This is your periodic payment at the end of every year. Part of it is interest, the part of it is principal. How do we split this interest and principal? Very simple. Take the principal balance at the beginning, 15,000 multiplied by 11%. The interest is 1650. So it means the first payment that you make at the end of the year is 31,830.23. If 1650 represents the interest part, the remaining should be the principal. The remaining should be the principal, that is 1533.23. This is your principal. This is your interest. If you just want to guess, you have to either select A or B because 1650 represents the interest part. We need to calculate the interest for the first year and the principal part for the second year. So it's going to be either A or B. Let us do the other part as well. We need to calculate what is the principal part in the second payment. Do not forget, we have already paid 1533.23 principal out of the total $15,000. So $15,000 less 1533.23 represents the principal payment in our previous part or previous year. The balance of principal is 13466 point something, that is 77. This is the principal on which interest would be charged at the rate of 11%. 13466 times 11% gives you 1481.34. Remember, this is the interest. This is the interest on your next payment. Since every payment is going to be 3183.23, out of this, if this is the interest part, the balance would be the principal. So 3183.23, the total payment, out of which 1481.34 represents interest. The balance 170.34 0.88 represents the principal payment. So this is the interest you paid in the first installment. This is the principal you paid in the second installment, and the total amount of each installment is 31,830.23. So that makes B to be the correct option. Interest element in the first installment and principal element in the second installment. So that makes B to be the correct option, and B it is. Next, given 5% discount rate, the present value of $500 to be received 3 years from today. To be received 3 years from today. This is not 5. This is going to be 3. Interest rate is 5. Present value is to be calculated. Maafi payments, there is no repetitive payment or annuity payment. So there's simply CPT PV and you will get your result. It's going to be 431.92, and it is approximately B. B it is. Next. An investor deposits $10,000 in a bank account paying 5% interest compounded annually. That is 5. Rounded to the nearest dollar, 5 years, the investor will receive what? So 5 is the interest rate, 5 is the 5. There are 5 periods involved. The amount of loan is, or what you have deposited, not loan, what you have deposited in the bank is negative 10,000. There are no periodic payments. You just have to calculate the future value. How much you will receive. Enter all these, press CPT FV, and you will calculate this amount to be a positive 12,760.82, which is approximately B. Straightforward question, no twist in it whatsoever. Nautil Industry has preferred stock outstanding that pays fixed annual dividend of this much. If an investor wants to earn 8.5%, how much should he be willing to pay for a share of Nautil preferred stock? You just have to calculate the present value of perpetuity, the income or dividend you receive divided by the desired rate of return. Straightforward question, no twist involved. It's 44.12, that's C. Now, this is a good one. It will cost $20,000 a year for 4 years when 8-year-old child is ready for college. This question needs some serious computation. I need full attention. It will cost $20,000 per year for 4 years when an 8-year child is ready for college. How much should be invested today at P0 or time 0 if the child will make the first of 4 annual withdrawals for the fee payment 10 years from today? 10 years from today. So a timeline would help in question like these, starting with year 0, 1, 2, 3, and so on, 8, 9, 10, 11, 12, and so on, whatever it might be required. Since the first payment is to be made at the end of 10th year, so it's going to be the first payment of 20K at the end of 10th year, and 22nd, 20, then 11, 12, and 13. This is the last payment on year 13, right? What should we invest now so that the child will receive 20K from year 10 onwards? We have to find what should we invest today. First of all, we will have to calculate what is the present value of these 20 payments to be received. If we discount them, they will represent the present value at year 9, right? So simply punch in 9 periods. First one is the 4 periods, first part. There are going to be 4 payments. 8% is the rate. It will calculate the PV at the end of year 9 for you, right? The payments that you will receive is 20,000. Future value 0. Simply enter these 4 for N, 8 for interest rate. Present value at the end of year 9th will be calculated because these 4 payments are from 10, 11, 12, 13 year. Discounting will bring them to year 9. So there is future value 0. Recursive payment is 20. Simply punch in CPT and present value. It will give you 66,242.54. That's the present value at the end of year 9. Since the second part requires investment phase, how much should we invest now so that the amount accumulates to 66,242 at the end of the 9th year? So basically this is what we need. This is the second part. This is what we want our future value to be. 66,242.54. This is what we want our future value of investments to be. What should we invest today for 9 periods at 8% with no regular payment, so as to accumulate 66,242, which will be enough for the child to withdraw 20,000 per month. So enter the numbers, press CPT PV, and there you go. You get your result. It's going to be 33,137.76. If rounded off gives you B to be the correct option. I hope people are following. Very good. All of you are getting correct results. Good. B is the correct option. Moving on. What will be $10,000 in future 5 years from now if the annual interest is 18 compounded monthly? Compounded monthly means 8 by 12, and 8 by 12 gives you 0.6667. That's the interest rate. 5 years, 12 months in 1 year, that means 60 periods. Since you're investing 10,000, it's an outflow. There is no periodic payment. Press CPDFE, and there you go, 14,898.49, and that is very close to B, and B it is. How much must be invested today at 0% to have $100 in 3 years? Since the discount rate is 0, the investment rate is 0, your present value now will be equal to your future value at the end of third year. There is no change. It is going to be same as the amount today. There is no future value. This is the same or the present value because the interest rate is 0. So it's going to be just 100, straightforward question, no twist involved. This one is little twisted one. A successful investor has decided to set up a scholarship fund for deserving students at her alma mater. Her plan is for the fund to be capable of awarding $25,000 annually in perpetuity. $25,000 annually in perpetuity. The first scholarship is to be awarded and paid out exactly 4 years from today. 4 years from today. The fund will be deposited into an account immediately and will grow at 4% compounded semi-annually. Since the withdrawals will be made on a yearly basis, so we have to convert this into effective annual rate for the foreseeable future. How much money must investor donate today in order to fund the scholarship of $25,000 per year from the end of the 4th year? So if you draw the timeline, now you're 1, 2, 3, 4, 5, and so on till infinity, till eternity. There's no fixed maturity. Now, this would be the first withdrawal by those who won the scholarship, second, and so on, and it'll go on till infinity. If this is what is to be received every year at the end of year 4 onwards, dividing this with, first we have to convert the effective annual rate, 4% compounded semi-annually. Let us change the numbers. Semi-annually means 2 periods in 1 year for compounding. What is the nominal rate? Nominal rate is going to be 4. Enter, up, compute. It's 4.04. So 4% compounded semi-annually is an effective annual rate of 4.04. So divide it with 4.04%. It will give you the present value of perpetuity. The present value perpetuity, this value is present at 3rd year. This is the present value at year 3. 25, 25, 25 till forever. If discounted, this amount represents the present value perpetuity at the end of year 3. That's an important point, because when we discount perpetuity, the first payment is on 4th year, so the discounting will bring the present value at the end of year 3. Now we have 3 periods. Rate is 4.04. What should we invest now? And we are not going to withdraw anything in these 3 years, so as to receive a future amount of 618,811.88. So what should we invest now to earn 4.04 effective rate for 3 years, so as to become this much amount at the end of the 3rd year? All variables have been entered. Press CPT and PV and you will get your result. It's 549,487. This would be the present investment now, which will accumulate to 618,811 at the end of the 3rd year, and this will start 25,000 withdrawal for eternity. Straightforward part was second. That this one was little twisted. We had to bring it to the end of year third, and then it required discounting to year 0. So that makes C to be the correct option. Moving on. A $500 investment offers 7.5 annual rate of return. How much will it be worth after 4 years? There is no periodic compounding, just annual compounding. So we're talking about 4 years, 7.5 rate, 500 is the payment. Now, no regular payments, just need to calculate the future value. Punch in these numbers, get your result, that is 668, and move on. Next, a local bank advertises that it will pay interest rate 4.5% compounded monthly on regular saving accounts. What is the effective rate of interest that the bank is paying on these accounts? I'm sure you know what to do. Use your interest rate conversion function. 4.5 compounding is done monthly. You just need to calculate the effective rate. That's going to be 4.59. That makes A to be the correct option. Straightforward question, no twist whatsoever. What is the effective annual rate if the stated rate is 12% compounded quarterly? I'm sure you know what to do. Punch in the numbers. Let's do this one for you. 12% is the nominal rate. Compounding is done quarterly. That is 4 times in 1 year. Effective rate would be 12.55. A. Straightforward question. A. Don't expect such question on exam. They are just for the sake of practice. Practice, practice, practice every question that you lay your hands on. 12.55%. Moving on to question 64. A local bank offers an account that pays 8% compounded quarterly for any deposits of $10,000 or more that are left in the account for 5 years. The effective annual rate for interest, same computation. Let us do this one as well, because simple questions. 8% compounded quarterly. 8 is the nominal rate. Compounded quarterly, we already have 4. Press CPT. It's 8.24. That makes A to be the correct option. Straight forward to the next part. It says, how much would the following income stream be worth assuming 12% discount rate, mean discounting? $100 received today, that is cash flow to year 0. $100, enter down arrow key. $200 received 1 year from today is going to be $200, enter down arrow key twice. Frequency is 1. Then we have $400 at the end of the second year, down arrow key twice. And finally $300 at the end of year 3, enter down arrow key twice. Press NPV, the system will ask for the discount rate, that is 12%. Enter 12, down arrow key, press CPT, and there you go. You get your result. Let's do it. Second clear function for TVM. All right, starting first cash flow we have for $100 year 0, enter. $100, enter down arrow key twice. I'm sure you would have got your result. It's 810.98. This is the present value. If you have cash flow streams this way, you need to calculate the present value, use NPV function, and you will definitely get your result. Doing this way will take time. Calculating the present value of each cash flows separately is time consuming. Use NPV function to get your result. Next, question 66. An investor who requires an annual return of 12% has the choice of receiving one of the following: 10 annual payments of $12.25 to begin at the end of each period, or 10 annual payments of $1,097.96 beginning immediately. Clearly this is annuity due and this is your ordinary annuity, and you will have to calculate the present value of both and select the one that is giving you more present value, or select the suitable option. So which of the option has the highest present value, and approximately how much greater is it than the other option? Let us first do the one with the annuity due. Second one is the annuity due. There are 10 payments. Second PMT, second set will bring your calculation to the beginning mode. 10 interest rate is 12% given here. We need to calculate PV. What is the amount? 1097.96. future value is 0, CPT PV, it will give you 6948.17. Don't forget to quit the beginning mode. Now try to solve this, the first A part, the A annuity. 10 payments. Each payment is of 1225. Interest rate 12%. No future value. Press CPT PV. You will get 6921.52. So clearly this annuity due is slightly better. By what amount? Calculate the difference between these two, and that will be 26.65. 26.65 would be the difference between these two present values, indicating that and option B is better, and it is better by $27. So that makes A to be the correct option. And as you can see, A was your right result. An investor makes 48 monthly payments of $500 each beginning today, annuity due, into an account that will have value of $29,000 at the end of 4 years. The stated annual interest rate is closest to. Now, $500 is the periodic payment, that is 500. We're talking about 48 such payment. Don't forget to set your calculator in the beginning mode for annuity due, beginning today. That's the indication it's an annuity due. 48 payments, PV is 0. The future value is going to be $29,000 in positive. Press CPT, press interest rates. What you will get? You will get monthly interest rate 0.753208. This is your monthly interest rate. Since we need the annual interest rate, just multiply this with 12 and you will get 9.08, which is approximately 9%, and that makes C to be the correct option. Speed and accuracy, gentlemen and ladies, that's what you need. Speed and accuracy, and that will come through practice and tons of practice, and you will get through in your first go. So we got the result, 9%. Moving on to the next part. Sarah Parker is buying a new $25,000 car. Her trade-in is worth $5,000. She's giving up his old car for $5,000. So it's the net amount that might be involved in our computations. She needs to borrow the difference, 5 versus 25,000. This is what she will borrow. The loan will be paid in 48 monthly installments, and the annual interest rate is going to be 7.5, which needs to be converted on monthly basis, and 7.5 upon 12 gives you 0.625. If the first payment is due at the end of the first month, ordinary annuity, what is Sarah's monthly car payment? We have to calculate the PMT. Now there are 48 periods. Interest rate is 0.625. The present value, the loan she's receiving is of $20,000. Simply press FV0, press CPT and PMT, and you get your result. It is 483.578, and that is C. There you go. Okay. Selmer Jones has just inherited some money and wants to set some of it aside for a vacation in Hawaii 1 year from today. His bank will pay 5% interest on any funds he deposits. In order to determine how much of the money must be set aside now in order to have sufficient money for the vacation and held up for the trip at the rate of 5%, how much should he invest now? So what he's talking about, is it opportunity cost? No, he's not giving up anything. Is it required rate of return? No, he's not making an investment. He just wants to calculate the present value of the future cash needed. So it is discount rate that we're talking about. That is C. Move on. An investor deposits $4,000 in an account that pays 7.5% compounded annually. Plug in 7.5 straight away. How much will this investment be in 12 years? N is 12, interest rate 7.5. Deposit that is being made right now is for $4,000. No periodic payment, CPDFV, and there you go. 9527, 9527.12. That's your result. Move on. Question 71. Mark Schmitz borrows this much to be paid back in 4 equal annual payments at an interest rate of 8%. The interest amount is in the second year of the payment. Now, this is again a kind of question we've already done. First of all, there are 4 periods. Interest rate is 8. The loan that he or she is receiving is $20,000. No future value. Calculate the payment that will be made. If you punch in the numbers, the periodic payment for 4 years would be 6038.42 straight away. Part of it is interest, part of it is the principal part. Let us first calculate what is the interest part. $20,000 is the loan, interest is 8, so that means 20,000 times 8%, $1,600 represents interest. Out of 6,038.42, 1,600 is interest. Take the difference, this will give you the principal part. 4,438.42 is the principal, right? It says the interest amount in the second year payment, just interest part in the second payment. So this is your first year payment, same as the second year payment, but let us see what is the interest part in the second payment. Now, total loan was $20,000, that's the principal. Out of this principal has been paid. This is the total payment. 6038.42 is the periodic payment. This is the principal part. If this has been paid, 44338.42, this would be the remaining principal. Interest would be charged on this remaining principal at the rate of 8%, and that gives you 1244.93. So what did we do? We calculated the payment, split the payment into principal part and interest part. This principal in the first payment was deducted from the total loan amount. This remaining principal, 15,561, it will attract interest at the rate of 8% next year. This is the interest part for the next year, and that makes C to be the correct option. C it is. Next. A major brokerage house is currently selling an investment product that offers 8% rate of return, compounded monthly. Based on this information, it follows that this investment has what? An effective annual rate of 8%. 8% compounded monthly. Effective annual rate would be more than 8%. This is wrong. Effective rate would be higher than 8%. Can't be equal to 8%. Periodic interest rate of 0.667. If you divide 8 with 12, since it's monthly period compounding, so 8 by 12 gives you 0.6667. That is true. Periodic interest rate of 0.667 per month, right? Stated rate of 0.830. This is totally wrong. Stated rate is 8%, annual percentage rate. So that makes B to be the correct option, and B it is. Next, an investor has the choice of two investments. Investment A offers this much interest compounded quarterly. Mark is A. Investment B offers interest rate at the rate of 7.40. Which investment offers the higher dollar return on investment of $50,000 for 2 years? So straightforward question. Let's first do this for investment A. In investment A, the rate 7.25 is compounded quarterly. If you divide it with 4, 7.25 by 4 gives you a quarterly rate of 1.8125. 1.8125. Yes. So how many quarters would there be in 2 years? We are talking about 2 years time. So 2 times 4, there are 8 periods. Interest rate is 1.8125. Right? We need to calculate what? We need to calculate the future value. What you are paying right now. The higher amount. This is what you are investing. $50,000 is being invested today. There is no periodic payment. We just need to calculate the future value by investing $50,000 in investment A. This will return 57,726.98 at the end of the second year. Now let's repeat the same with investment B. Investment B, it says 7.40 and it's straight away annual rate, no compounding every year. So it's simply 7.4, 2 periods, same investment, $50,000, no periodic payment. Calculate the future value. This gives you 57,673.80. Compare the difference between these two. This is slightly better by how much? $53.18. So investment A offers slightly better return. So go for investment A because it offers 53.18 greater return. So in this case, B would be the right option. B it is. Which of the following is most accurate statement about stated and effective annual interest rate? The stated annual interest rate is used to find the effective annual interest rate. Yes, we use APR to calculate effective rate. Look no further. That's your right answer. The stated rate adjusts for frequency of compounding. No, effective rate adjusts for frequency of compounding. This is incorrect. So long as interest is compounded more than once a year, the stated annual rate will always be more than, will be less than effective rate. This we have just discussed a little while earlier. Effective rate, the period of frequency, when it increases, your effective rate goes up. A is the right answer. A share of George Company preferred stock is selling for 65, pays dividend of 4.5 per year and has perpetual life. What is the rate of return? Very simple. We know the present value perpetuity is calculated by dividing the return with the rate. Since we do not have the rate can be calculated by dividing 4.5 with the value given 65. 4.5 is the return, 65 is the current price. 4.5 upon 65 times 100 gives you 6.923, which is approximately 6.9%. We were given the price of the stock, we were given the return, we just had to calculate the percentage return, and that is 6.9. A is the right result. Next. T-bill yields can be thought of as what? T-bill yields can be thought of as nominal risk-free rate because they contain an inflation premium. Yes, T-bill contain an inflation premium. They are default risk-free, yes, but still they have nominal risk-free rate embedded in them. They contain a premium for expected inflation. Now, the question that you may ask, how can a person who has not read the book or curriculum or Kaplan can solve these questions? When he will solve this question, he will learn that nominal risk-free rate includes inflation risk premium for T-bill yield. So everything that might be missing, every holes that might remain will be filled through questions. And that's what is needed. The quickest way to prepare for the exam is to do questions. That's my philosophy, and that's what we do repeatedly in FTC. Question 77. Assuming a discount rate of 10%, which stream of annual payment has the highest present value? This question requires little intelligent thinking. Do not start discounting every cash flow and then select the right option. Use common sense. We have 3 cash flows. This is for year 1, 2, 3, and 4. Let us first see B. Since cash flow B's, there are 3 outflows, year 1, 2, and 3, with a single cash flow coming at the end of the period or the project. When you calculate the present value, this 500 is far away from current time period. So this discounting will result in very little NPV for the positive. And we have 3 significant cash flows. So its NPV will be comparatively lower. Now compare A and B. A will give 20 in the first year, -5, 20, and 110 at the end of the 4th year, maybe 3rd year. We haven't been given exactly whether they are from year 0 or starting at the end of year 1. So we do know that it's 110 at the end of the period and here 110 at the start. Since C project or C investment is front loaded, 110 is close to the 0 point, so its present value would be higher than A. So we can just use our intuitions and we can get the right option. C is the better one because it is front loaded. The cash flows near year 0 is 110, 20, so this would be a better option than AB. So that makes C to be the correct option. Next, if $2,000 a year is invested at the end of each of the next 45 years in a retirement account yielding 8.5%, how much will an investor have at retirement of 45 years from today? No compounding in a period, simply yearly compounding, 45 periods, 8.5% is the rate, present value 0, regular recursive payments $2,000, you just have to calculate the future value, punch in the numbers, you get your result. 901,060 is the future value of 2,000 periodic payments for 45 years compounded at 8.5% per year. So that gives you C to be the correct option. Moving on to question number 79. An annuity will pay 8 annual payments of $100, 8 of $100 each, with the first payment to be received 3 years from now. If interest rate is 12% per year, what is the present value of this annuity? Now, first of all, if you draw the timeline, that makes things little easier for you. 0, 1, 2, 3, 4, 5, and as many marks as it might take. Since we will receive 8 such payments starting at the end of year 3, means the first payment will be from here 1, 2, 3, 4, 5, 6, 7. So we're talking about year 3, 4, 5, 6, 7, and 8. Or is it 8 payments? 1, 2, 3, 4, 5, 6, 7, one more. Alright, so these are the payments we'll start receiving at the end of year 3 onwards. Right? What is the present value of this annuity? We know, since they are 8 payments starting at the end of year 3, if we discount them, these 8 payments, the discounted value will arrive at the end of year 2. It will be PV at the end of year 2. Right? And then PV at the end of year 2 will be discounted back to year 0. So which is the correct option? An ordinary annuity of 8 periodic payments of, it is an ordinary annuity, but the present value is a 2-step process. First, discounting at PV2 and then discounting at year 0. Wrong. A lump sum discounted for year 3, not for year 3, rather it's for year 2, where the lump sum is the present value of an ordinary annuity of 8 periods at 12%. This part is correct. 8 periodic payments of 100 each discounted at a certain rate, but this part is incorrect because we will be discounting from year 2 backward to year 0. C is correct option. A lump sum discounted for 2 years, where the lump sum is the present value of an ordinary annuity of 8 periods at 12%. Perfectly correct option. 8 payments starting at the end of year 3 onwards. When we'll discount, it will discount at the end of year 2, and then we need to discount for 2 years, giving C to be the correct option, and C it is. Next. Which of the following statements best describe the components of required interest rate on a security? There we go. Required interest rate on a security is nominal risk-free rate plus default risk premium plus liquidity risk premium plus maturity risk premium. Those who haven't read the text, they will rediscover the idea from the questions. It's right here. If your whatever learning system you're using, curriculum questions or Kaplan or FinQuiz or IFTs or whatever you're using, if it covers the syllabus thoroughly, every question should cover every component of your LOS. Right? So, required rate of return, we can discover this idea from this question. It is sum of these 4 components, and nominal risk-free rate itself is a combination of real risk-free rate plus expected inflation. Right? So, if you see this arrangement is in front of you, you will correlate this with the given options. Look at option B. It's the sum of real risk-free rate, yes. Expected inflation, yes. These two feed into the last arrangement, plus default risk premium, yes, plus liquidity premium, and the associated risk for maturity. Perfect. B, that contains all the elements of your nominal required rate of return. B is the correct option. Right? Next, what is the total present value of $200 to be received 1 year from now, 300, 3 years from now, 600, 5 years from now? What is its present value? First of all, this 300 is coming at the end, this 200 is coming at the end of year 1. 300 to be received in 3 years, this is right here. And this 600 is coming at the end of year 5. So there is no cash flows in these intermediate years. You use NPV function, 0 enter down arrow key once, 200 enter down arrow key twice, enter down arrow key twice, enter down arrow key twice, 0 enter down arrow key twice, enter down arrow key twice. Then you press NPV, the system will ask for the discount rate, that is 5%, enter down arrow key CPT, and you will get your NPV straight away. It's just that you need to use NPV function. It will be easier for you to get your result, and this will give you 919 point something, 0.74. That's B is the correct option. You borrow $15,000 to buy a car. That's what you receive right now. The loan is to be paid off in monthly payments over 5 years at 12% annual interest. What is the amount of each payment? Since you would be making monthly payments, interest must be converted on a monthly basis, that is 1%. In 5 years, you will have 60 payments or 60 periods. What should be the size of each payment? If future value is 0, punch in 60 for N, 1 for interest per period, PV 15,000, FV 0, press CPT PMT, you get your result. That is 3.333.667. That is approximately 334. That's B. Louis Weaver wants to have 1.5 million in the retirement fund when she retires in 30 years. If Viva can earn 9% rate of return on her investments, approximately how much money must she invest at the end of each of the next 30 years in order to reach her $1.5 million goal? It's a lot of money, by the way. $1.5 million to be invested for 30 periods, 30 years at the rate of interest 9%. Mafi fee present value. What should be the payment? Punch in 39, 0 and 1.5 million. Press CPD PMT, you will receive 11,004.53. This should be every yearly investment so as to accumulate 1.5 million by the time 30 years are over. That makes B to be the correct option. A recent ad for a Roth IRA includes the statement that if a person invests $500 at the beginning of each of the month for 35 years, they could have 1 million for retirement. Mind the word beginning each year. That's annuity due. Investment is to be made right now. They could have 1 million for retirement, assuming monthly compounding. What annual interest rate is implied in this statement? First, second PMT, second set. This will bring your calculator to beginning mode. Since we are talking about 35 years and we are talking about the monthly compounding, that means 35 times 12. How many periods would there be? 420 periods. 1 million is what we want at the end of the investment period. Present value is 0. We want to calculate the periodic payments. We want to calculate interest. A periodic payment is given $500. This is the periodic payment, $500 in negative. Remember, it's outflow. This would be inflow at the end of 35th year. Okay, so what we're going to calculate, we're going to calculate the interest rate. It's going to be 0.6176. This is the monthly rate. Multiply this with 12, you get 7.411, and that makes B to be the correct option. If $2,500 were put into an account, this is the pointer here. If $2,500 were put into an account at the end of each of the next 10 years, earning 15% annual interest, how much would be in the account at the end of 10 years? 10 years, 15% is the rate, present value 0. We are investing $2,500 at the end of every year. What should be the future value? Tuck, put in the numbers, punch in the key, CPDFE, and you get your result. It's 50759.30, as simple as that. Next, a local bank offers a certificate of deposit that earns 5% compounded quarterly, divided with 4 gives you 1.25% quarterly for 3.5 years. That is 3.5 years. There are 4 quarters in 1 year. That makes a total of 14 periods. If depositor places 5,000 deposit now, what will be the value of account at maturity? Since there are 14 periods, this is the rate. Investment made of $5,000. Mafi regular payments, no regular consistent recursive payments. Press CPDFE. You will get the future value of this investment, and it's going to be 5949.77. Extract the information carefully, plug it in the calculator, and that's punch the keys, you get your result. And that's how things work in professional certifications. Doing questions, solving problems, not recitations. An individual borrows $200,000 to buy a house with 30 years mortgage, requiring payments to be made at the end of each month, ordinary annuity. The interest rate is 8% compounded monthly, means 8 by 12 gives you 0.666667. Since we are talking about 30 years, each year with 12 months means 360 periodic payments. 360, interest rate 0.6667. Present value, the loan that you have received right now plus 200,000 inflow, right? What should be the periodic payment if FE is 0? Punch in these numbers, extract it from the question carefully, plugged it in the calculator, press CPD, PMT, and you get your result, 1467.53. There you go. Next, Steve Hall wants to give his son a new car for his graduation. If the cost of the car is $15,000 and Hall finances 80% of the value, means 80% of 15,000, that is what funding should be for $12,000. 36 months, 8% annual percentage rate, 8 by 12, we know 0.66667. And we're talking about for how long? We're talking about 36 months. 36 months, this is the rate. Loan that you have taken, positive $12,000. we need to calculate the periodic payment. Punch in these numbers, press CPT PMT, and you will get 376 point whatever. This is the periodic payment you will have to make for this loan arrangement. Concerning an ordinary annuity called OA and an annuity due called AD with the same payments and positive interest rate, which of the following statement is most accurate? There is no relationship. Wrong. There is. The present value of ordinary annuity is greater than the annuity due. Wrong. Present value of annuity due is more than the present value of, in fact, its present value of annuity due, it is greater than the present value of ordinary annuity. Why? You haven't read the book. You have thrown it away in the trash bin. Then you will know it from the given detail given at the end of the question that present value of annuity due is 1 plus R% of present value of ordinary annuity. Since there is a non-zero interest rate, so PV of AD will be greater than PV of ordinary annuity. So that's the reason present value of ordinary annuity is less than the present value of annuity due, or the present value of annuity due is greater than the present value of ordinary annuity. That makes C to be the correct option. And there we go. In 10 years, what is the value of $100 invested today at interest rate of 8% per year compounded monthly? 8 by 12, we have memorized this, it's 0.6667. We're talking about how many years? You're talking about 10 years, 10 times 12, 120 periods. Interest rate 0.6667. Present value minus 100. That's the payment every period. What do we need? No regular payments. You need to calculate the future value. Plug in the numbers. Press CPT-FE. You get 22196, and that gives you B to be the correct option. And that's all.